So let us now continue our discussion. Okay, so can you guys see my screen now?
Yes, sir.
All right. So uh, let me just confirm. How many of you were able to get this one up to this part? 101. Just give me a thumbs up if you guys were able to get up to this point. Okay, one, two, three. All right. So I guess maybe half of you. How about the others? Okay, could you please raise your hand who wasn't able to get the idea on how did we get this 101 right here? Okay, one, two, one, two, three. All right then. So there's three of you who wasn't able to get this one. All right. So let me just repeat it. Okay, because with that it's a lot easier. All right. Oops. Okay. So let's do the process again. So 0 minus 1. Okay, how do I lower their hands? Lower hand, lower hand. Okay, good. So 0 minus 1 is cannot be. So we have to borrow to this guy. So this one will become 0. Okay, and then this 0 now will become 10. So now we can subtract this 1 to here since it's now okay or enough. So 10 minus 1 is 1. 1 minus 0 is still 1. Okay, moving on. So 0 minus 1 is cannot be. So we have to borrow to this guy. But then again, this guy doesn't have anything. So he has to borrow first to his neighbor. Wherein this one has something. Wherein, of course, 1 now will become 0. 0 will become 10. Okay. Now, you can now borrow to this guy since he has now a money. So 0 will become 10, and then 1 will become 1. Okay? Clear so far? Miss Karil? Saan pa ba yung iba na nakuha? Okay, how about you, Miss Karil? Okay, good. Now, since this one now is 10, then we can now deduct it right here. So 10 minus 1 is 1. Minus 1 is 0. Okay? So 1 right here minus 1 is now 0. So let me just cancel this one out. So we can have an easier way of subtracting things. So 0 minus 1 cannot be. Okay, so we have to borrow to this guy. But then again, this guy doesn't have anything. So he has to borrow to his neighbor first before he can let us borrow something or money. Okay, so 1 will become 0, and then 0 will become 10. Now we can borrow to this guy since he has now a money. So 10 will become 1, and then this 0 right here will become 10. Okay, so 10 minus 1 is 1. Okay, clear? Is it okay now? Okay, good. All right, so moving on. So 1 minus 1 is 0. So let me just cancel this one out. The same with this one. So this one now is 0. So 0 minus 1 is cannot be. So we have to borrow to this guy. But then again, he doesn't have anything. So he has to borrow to his neighbor first. So 1 will become 0. And then 10 I mean 0 will become 10, and then this 10 now will become 1, and then this 0 will become 10. Okay, so 10 minus 1 is 1. Moving on, 1 minus 1 is 0. 0 minus 0 minus 0 is still 0. 1 minus 1 is 0. So let's just cancel this one out. 0 right here. 0 minus 1 is cannot be, so we have to borrow to this guy. So this 1 will become 0, and then this 10, this 0 will become 10. Okay? 10 minus 1 is 1. 0 minus 0 is still 0. But 0 minus 1 is cannot be, so we have to borrow again to this guy. But then again, this guy doesn't have anything, so he has to borrow to this neighbor of him. So 1 will become 0. 0 will become 10. Okay, so now we can borrow to this guy now since he has something that he can let us borrow. So 10 will become 1, and then 0 will become 10. Okay, and then 10 minus 1 is 1. 1 minus 1 is 0. 0 minus 1 is cannot be, so we have to borrow this guy. So the same process, so double borrowing since he cannot, or we, this guy cannot let us borrow anything. So we have to borrow to his neighbor first. So 1 will become 0, and then 0 right here will become 10. So from here, we can now borrow to this 10 right here. So 10 will become 1, and then 0 will become 10. So 10 minus 1, okay, is 1. Minus 1 is 0. Okay, 1 minus 0 is 1. And 0 minus 0 is 0. Okay, and then just group this by 4. So 1, 0, 1, 1, 0, 0, 1, 1, and then 0, 0, 1, 0. Okay, so this is now the answer for the number 3. So did you guys get it so far? So don't forget the base or the labor or the unit, which is 2. So are we clear so far? So I know it might be super tricky unless you yourself is going to do it. So that is why I encourage you guys to answer the number 1, 2, and then 4. Okay. And then if you're not sure with your answer, so yeah, you can message me, and then maybe you can send me a picture of your practice activities or exercises, and then yeah, I'll check it for you, and then I will let you know if you did correctly or no. Okay. Anyway, that's it for the binary subtraction. Our next one right here is octal addition. Okay. So nothing special. However, all you need to do, let's go back with our list of decimals and hexadecimals before. Decimals, hexadecimal, and then octal. Okay, so let's deal with the octal first. Just bring down the hexadecimal right here. Oops. Okay, so let's just recall it. Why is it not aligned? Anyway, so in decimal, so no problem. So it's the same with how we count. Well, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 6, 27, 28, 29, 30, 31, 32, 33, 34, 35. So let's have up to 35. Now again in octal, so 0 to 7 is the same. 4, 5, 6, 7. However, in 8 and then 9, so we don't 8 and 9 in here. So we skip those 8 and 9. We'll go straight to 10. Okay, and then 9 is 11, and then 10 is 12. Okay, let me just align this one. Okay, and then in here, just continue this one. 10, 11, 12, 13, 14, 15, 16, 17. So again, we don't have 18 and 19, so just skip those two. So next to 17 is 20, 21, 22, 23, 24, 25, 26, and then 27. So again, from here, we don't have 28 and 29, so just skip those two again. So 30, 31, 32, 33, 34, 35, 36, 37. So the same process, we don't have 38 and 39, just skip those two. So 40, 41, 42, and then 43. Okay? So in here, 2 plus 3 is 5, so it's the same. And 1 plus 5 is 6, so it's the same, so no problem. However, in here, 7 plus 1, okay, oops, okay, wait a second. All right.
Sana all.
Okay, so sorry for that. Okay, let's go back in here. So 7 plus 1 is 8 in decimal. Okay, so 7 plus 1 is 8 in decimal. However, in octal, it's equal to 10. Okay, so that is why we have carry 1, bring down 0 right here, or it's 10. Okay, so 3 plus 2 is 5, plus 1 is 6. Okay, so are we clear so far? Were you guys able to follow? So 27 plus 31 is 60. Okay, in octal. All right, so there's only one who was able to get it. How about the others? Okay, good. So most of you were able to get it. Okay, so let's answer letter E. Okay, so 37.77 and then 16.54. Okay, so 4 plus 7 is 11 in decimal. Okay, 11. However, in octal, it's already 13. So we have to put here 13. So carry 1, bring down 3. Okay, so 1 plus 7 is 8, plus 5 is 13. So 13 in decimal, but in octal, it's 15. So carry 1, bring down 5. Okay, so the decimal point will go here. 6 plus 7 is 13, plus 1 is 14. So 14 in decimal, but 16 in octal. Okay, so 1 and then bring down 6. And 1 plus 3 plus 1 is 5. So yeah, this one is in octal. This one is also in octal. Okay, so that's how we add octal. Okay, so are we clear so far? Okay, very good. Well, actually, there is a pattern, okay, in here. So the first, so yeah, let me just put it like that. Into 7, and then like that. Right. So the first 0 to 7 is the same, but 10 to right here, 8 to 15 is actually already plus 2 in octal. So if you're going to take a look on this one, it's plus 2. And then 16 to 23 is plus 4. Okay, 23 plus 4 is 27, 20 plus 4 is 24. And then 24 to 31 is plus 6. Okay, and then here and above is now, plus 8, and then plus 10, and then plus 12, and so on and so forth. So yeah, it's the pattern that I can provide you guys, to make it much more easier to understand. But then again, just list everything from 0 to 35, then I guess you are already good to go. Okay, so yeah, that's it for the octal addition. And what about hexadecimal addition? Okay, so before we proceed in answering this one, let's list all of the hexadecimal sequence. So 0 to 9 is the same. 4, 5, 6, 7, 8, 9, and then 10. Okay, however, in 11, let me just bring this one above. We had decimal. Okay, however, in 11, it's already letter A, capital letter A, B, C, D, E, and yeah, up to E only. Okay, and then for the 16, all you have to do is continue this one. Okay, oops, my bad. This one is A, this one is B, this one is C, this one is D, and then E, and then F. Okay, so that is why it feels like something is missing a while ago. Anyway, so yeah, it's A to F, 10 to 15. But in 16, all you need to do is continue this one. Okay, so now next to 9 is of course 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So yeah, it's quite the same. So 0 to 9, 0 to 9, and in here it's 10 to 19. So of course, after this sequence of number, it would be letters. Okay, again. But instead of, let's say, G, H, I, J, K, so I'll just add 1 in here. Okay, 1A, 1B, 1C, 1D, 1E, 1F. Okay, let me just align this one. There you go. Okay, and then for the 32, so once we're done with F or 1F, so all we need to do is continue this number. Okay, so next to 19 is 20, 21, 22, and then 23. Okay, so I guess that's already enough. So in here, 4 plus 6 is 10 in decimal. However, in hexadecimal, it's already letter A. So that is why we have A in here. Okay, and then 7 plus 2 is 9. So that's how we've got this result right here. So clear so far? Okay, how about the others? Anyone who's confused? Please let me know so we can discuss it over again. Okay, so I guess half of you again were able to get it. Anyway, so let's have more example. So 7 plus 9 is 16 in decimal. So 16 in decimal, but in octal it's 10. Okay, so we have to carry 1, bring down 0. Okay, so 1 plus F plus E. So F is 15, F is 15, and then E is 14. Okay, so 15 plus 14 is 29, plus 1 is 30. Okay, so 30 in decimal, but in hexadecimal, it's 1E. So that is why we have 1E in here, or carry 1, bring down E, and then bring down that carry right here. All right, so did you guys get it so far? And how did we get this 1E? So all you need to have is this list of, sequence, decimal, hexadecimal, and then octal. Okay, so again, 30 is equal to 1E. So you can add it as normally as decimal. Then again, if it's in hexadecimal, so we have to get the equivalence of that one, which is 1. Okay, so I guess that's already enough. Having this example letter B is already good for you to, have up to this uh, point. So if you have more, then just keep on doing this one. So instead of 1A, this one will become 2A, 2B, 2C, 2D. So for the number, I guess it's, no problem. So 0 to 9, 10 to 19, 20 to 29, 30 to 39. And in letters, it's A, B, C, D, F, 1B, 1C, 1 to 1F, 2A, 2B, 2C, 2D, 2F, and so on and so forth. Okay? All right, so that's it for the hexadecimal. So here are the other sample problems wherein we will not answer this one anymore since we don't have that much time. So again, I'll leave this one to you guys as your practice assignment, your practice activity, right? And then we also have here multiplication of binary numbers, wherein it's super the same with how we solve things, or how we multiply things. So 0 times everything is of course 0, and then 1 to this, first operand, just copy as it is. Okay, 1 0 1 1. Okay, and then 0 again is of course everything is 0, and then 1 again is just copy again everything, and then from here, so it's like uh, double process. So for multiplication you need to apply binary addition. So 0, bring down 0, 1 plus 0 is 1, 1 plus 0 is 1, 1 plus 1 is 10, so carry 1, bring down 0, 1 plus 1 is 10, carry 1, bring down 0, 1 plus 1 plus 1 is 11, carry 1, bring down 1, 1 plus 0 is 1, and then 1, and then just bring it down. Okay, so yeah, very straightforward. Okay, just multiply it on how we multiply things in in a normal way, and then in here just apply the binary addition. So were you guys able to follow? Okay, so to Mr. Pasito, it's already good. How about the others? Okay, Mr. Rex, very good. Miss Karil, okay, very good. Mr. Christian, okay, very good. Mr. MG. All right. So yeah, that's how we multiply binary. Okay, so another exercises wherein I'll give this one, or I'll leave this one as your practice exercise. And then in here, so in here you need triple process. Okay, so you cannot multiply this one right away. So you have to convert this 42 in here into binary. So the same with this one into binary. And then the binary result of that one, that's the one that you're going to multiply. Okay, something like this. Okay, and then whatever is the result down below, you're going to apply binary addition. So yeah, in here, if it's not in binary formation, you have to convert that one into binary before you can perform multiplication of binary numbers. Okay, so clear so far? So that is very important. Okay, you cannot multiply this one as soon as possible. You have to convert this 42 into binary before you can multiply it. Okay, clear or no? All right. So I'm not convinced. So let's just answer this one. Okay. So let me just show you how it's done. So again, you cannot you cannot multiply this one as soon as possible. You have to convert this one into binary. Okay. 42. So in binary, this one is 16, 32, 16. This is 48. So this is 0. 42, 0. So this is the binary representation of this 42 right here. Okay, so 32 plus 8 plus 2. Okay, and then 21 is, so you don't need 20. All right, 16. 1, 2, 4, 8, 16. Ah, my bad. So this is not, okay, this is not 32. This is 16. So this is 0. And then right here is the one that is 32. Okay, so it's 0, 0, 1, 0. And then for 21, so we need 16. So 1 right here plus 5. So 0, 1, 0, 1. Okay, 4 plus 5, 16. Yeah, okay, there you go. And then from here, we can actually remove those 2 and 3 zeros. So let me just transfer that one right here. So it's 10 zeros, 0, 1, 1, 0. And then in here it's 1, 0, 1, 0, 1. And then in here you can now perform multiplication. So if it's 1, just copy everything, okay, as it is. If it's 0, then just make everything 0. If it's 1, again, just copy everything. So 0 right here, 1, 1, 0, 0, 1. If it's a 0, again, just make everything 0. And next one is 1, so just copy everything. 1, 0, 0, 1, 1, 0. Okay, and then from here, you can now perform binary addition. Okay, so this one now is super easy. 0, 1, 1, 1, 1 right here. So 1 plus 1 is 10. Bring down 0. 1 plus 1 is 10. Carry 1. Bring down 0. 1 plus 1 is 10. Carry 1. Bring down 0. 1 plus 0, 0 is 1. And then bring down 1. So yeah. And then from here, since it's in octal, okay, so you need to convert. So I'm sorry, it's not triple conversion or triple process. So it's quadruple. Okay, so this one is in a form of binary, so we have to convert this binary into octal. So again, in octal, we have to group this one by 3. Okay, so 0, 1, 1, 1, 1, 0, 0, 0, 1, and then 1. So just to complete this one by 3, or by 3 bit, just add 2 zeros. Okay, and then 1, 1, 0 is 1, 2, 4 is 6, and this one is 3, and this one is 4, and this one is 1. Okay, so 1, 4, 3, 6 base 8. Okay, so 42 times 21, okay, is equal to 1436 base 8. Okay, all right. Okay, so were you guys able to follow on how did we get this 1436 base 8? I'll put here the base, so that you don't mistook it as another number or another part of this one. So were you guys able to get this one? Hello? Anyone? Or none? Okay, so how about raise your hand, okay, if you didn't get this one. Okay, there's 1, 2, 3, 4. So most of you. Okay, so let's have more example. Again, I'll just list here the steps. So if it's octal or hexadecimal, okay, and then it is asking you to perform multiplication, okay, so you need 4 process on this one, okay. The first step is you have to convert that octal or hexadecimal into binary. Convert into binary, okay. So once you've got the binary, then you can now perform multiplication, okay, out of that binary. Okay, let me just bring down our lower hands. Oops, why asked to unmute? Sorry, not that. Okay, and then the third one, once you've done the multiplication, so perform addition. So in here, I'll just put binary multiplication. And in here, perform binary. And then lastly, bring it back to octal or hexadecimal. So this one is octal to, binary to octal or hexadecimal. Okay, so let's go back in here. Okay, let me just, so this is the first step. Okay, we've transformed this one into binary. Okay, and then we've just simplified it by removing the two zeros in here and then three zeros in here into something like this. So we are still in first step, and then in here we are now in second step. So we are now performing the multiplication part in here. So once you're done in this one, so we can now perform addition. So this is now your third step, okay, after adding this one. Okay, and then lastly, since we this one is in a form of octal, so we have to bring this uh, binary, or we have to convert this binary into octal. Okay, so again, in octal you need 3 bits, or you have to group this one by 3 bit. So that's what we did. So 3 bit 110, which is this one, and then 011, which is this one, and then 100, okay, which is this one, and then just another 20 right here just to complete that one as another 3-bit group. And then from here we can now what is that one? We can bring that one back now to its original uh, format. So 110 is 6, 011 is 3, 100 is 4, and then 001 is 1. Okay, so that's how we've got this 1436 right here. Base 8. So I hope that one now is clear to you guys. Is it okay now? So it's for process. All right. So would you please raise your hand or give me a thumbs up if you guys were already able to get it. Okay, 1, 2, 3, 4. Okay. How about the others? Okay. So raise your hand. Just raise your hand if you wasn't able to get it. All right. So I guess none anymore. Okay. So yeah, that's it for the multiplication. So again, I will not answer the others anymore since we don't have enough time anymore. So the next one right here is sign binary numbers. So sign binary numbers, or from the word sign, okay, we only have two, of course. So it's either plus or minus. But mostly, if there is no sign indicated, that's already considered as positive. Okay, no sign. But if you want to represent that number or that expression into negative, so that's the time that we have to put negative, okay, with sign, okay. So let's say positive 150 is the same with positive 150. But in negative, so you need to put negative sign in that. So it's equal to negative 150. However, in computers, okay, we don't have positive we don't have positive and negative. Okay. In computers, we only have numbers, okay, and letters to be exact. But then again, the most foundation of how our computer reads the data is via binary only. Okay, it's either 0 or 1. 0 for off and then 1 for on. Okay, so that is why if we are going to represent this 150 into negative 150, so it's still in a form of 1 0 or 0 or 1. Okay, so depending on the combination. So that's how it lead us to this sign magnitude, or two's complement process to be exact. Okay, so if you want to represent positive 9, okay, just keep that as it is. Okay, wherein we will not change anything. So that is why it's still 0 in here, 0 0 0 0 1 0 0 1. So in here it is a value which is 9, and then the second 4 bit in here is the representation of your sign. Okay, so if it's 0, then it's positive. However, if you want to represent this 9 right here into negative, then just make that 0 into 1. Okay, so that is why negative 9 right here is 1 0 0 0 1 0 0 1. Clear so far? Alright, so there's only one. Give me a thumbs up. Anyway, so but basically this is just the concept, okay, of a human being. But in computer we have different process, so we will discuss that one later on part 3, since we don't have enough time anymore. So goodbye for now and see you guys on part 3.